Hello everyone, this is Ramji Sharma. Let's brush up some algebraic skill required for calculus. In this video, we will simplify algebraic expressions, factor algebraic expressions of type a squared minus x squared, factor algebraic expressions of type ax squared plus bx plus c where the first coefficient a equals 1, find the value of an algebraic function at a point, and find the value of a piecewise defined function at a point. First of all, let's look at some of the examples to simplify the expressions. First one is to simplify x squared minus 3 times x plus 4 minus 8. So in this example, let's just do it down here. So let me copy that expression down here. X squared minus 3 times x plus 4 minus 8. Now we can distribute the negative 3 inside this parentheses, and remember to change the sign after you multiply inside by the negative. If we do that, then we have x squared coming from the first line minus 3 times x is 3x, and minus 3 times plus 4 is going to be negative 12 minus the 8 from the previous line. Then we can combine these 12 and 8 together and get the final answer, which is x squared minus 3x minus 12 plus 8 is 20. This is our final answer. Now look at the second example. Example number part B. Here we have to simplify x squared minus a minus b times x plus 6. If you look at the middle term, it has a minus sign outside the parentheses and x at the end. So we have to distribute the minus and x inside simultaneously. If we do that, then we have x squared from the previous line minus, and then we multiply x and a, which is ax, and then we multiply minus and minus, which is a plus, and then also multiply b and x, which is bx plus 6. Then we can not simplify it any further than this, because we cannot combine anything else here. You can factor out x and then it goes back to the previous line. Here the goal is not to factor but simplify, multiply and add, subtract. Now let's look at part C. Here we have to multiply two binomial expressions, which are x minus 2 and x minus 3. Now if you remember the FOIL method, which is first, outside, inside and last, you probably already know how to do it. I am going to show a similar method here, which you already know. So it's going to be the first x times x, which is x squared, and then x times 3 with a minus sign there, so that's going to be negative 3x, and then negative 2 times x is a negative 2x, and negative 2 times the negative 3 is going to be a positive 6. And we can now add these two like terms and get the final answer. Our final answer is going to be x squared minus, after adding 3x and 2x, we got a 5x and plus 6 is our final answer. Now later in this video, we will see how we can break this x squared minus 5x plus 6 into the two factors x minus 2 and x minus 3. At this time, pause this video and work on part D. Okay, so I hope you paused it and worked on it. Let me show the work, and you can check your work with my answer here. Here we have x plus 1 and 3 minus x. Using the FOIL method, we have x times 3, which is 3x. I'm going to put the number first and the letter. And then minus x times x is x squared, and then plus 1 times 3 is a 3, and plus 1 minus x multiplied together will give us negative x. Now we can move the term containing the highest power to the front, so we get negative x squared at the front, and then you can combine x and 3x, which is gonna give us, you subtract basically, so 3x minus x is 2x, positive 2x, because the positive is bigger, plus 3 as our final answer. So I hope you got the same answer as mine. Let's move on. The next example we have is to expand or simplify these types of expressions where we have a plus b squared or a minus b squared. We can do this thing using the FOIL method or using a direct formula. Formula that I am going to be using mostly in this course is the following: a plus b, so let's call it a formula. So a plus b squared, or quantity squared if you like that way, is going to be a squared plus 2ab plus b squared, and a minus b squared equals a squared minus 2ab plus b squared. So the only difference between these two is the second term, right? Yeah, the second term is positive. You have a positive inside the parentheses, and a negative if you have the negative inside the parentheses. The last term is always going to be positive. Now you can prove these formulas using the FOIL method, because a plus b quantity squared is the same as a plus b times a plus b. So a plus b squared equals a plus b times a plus b, and if you follow the same procedure as we did in the FOIL method before, you can come up with this answer here. And with the minus sign, of course, the last sign is going to be minus. Anyways, we're going to do these two examples using the FOIL method as well as using the formulas. And later on, we'll always use the formulas instead of using the FOIL method to save some time. Alright, so let's look at x plus 2 squared, which by this definition here is going to be x plus 2 times x plus 2. Now if I apply the FOIL method, then I have x squared plus x times 2 is 2x, plus 2 times x is again 2x, plus 2 times 2 is 4. Again, remember, I always put the number first and the letter later. So that's going to be x squared plus 2 plus 2, 4x plus 4. This is one method, but this is going to take a little bit of time. To speed this process, you can apply this formula. So if you apply this formula, let's call it a second method. And this is the preferred method to the first one. So we have if we compare x plus 2 quantity squared with a plus b quantity squared, we can identify a as x and b as 2. So a equals x and b equals 2, because the first term you can think of this as a, and the second term you can think of this as b. and the formula is a squared plus 2ab plus b squared. So it's going to be x squared plus 2 times a is x plus b 2 times a plus times b. Let me erase this thing here. So a times, hold on a second. Okay, I got that out. So 2 times a times b is another 2 plus 2 squared. And if I simplify this, this is going to be x squared plus 2 times 2 is 4x plus 4. So later on we can quickly write this as x squared plus 4x plus 4 by doing the calculation of the middle coefficient in our head, like 2 times 2 is 4. So that should be pretty quick after you practice similar problems like this. Now pause this video and work on part B. Well, I hope you worked on part B by now. So let's do this here, and then you can compare your answer with my answer. In part B, we have few more terms. So we have 2x minus 3 minus x squared. Now remember, this square is applied to 3 minus x, and this negative sign is outside. So do not distribute the negative sign inside yet because of the square. The first thing you have to do is always work inside the parentheses, which in this case is the quantity squared. So I'm gonna quickly apply the formula for a minus b quantity squared. So if it is a minus b quantity squared, that's going to be a squared minus 2ab plus b squared. So in my case, a equals 3 and b equals x. So it's going to be a squared, which is 9, minus 2ab, 2 times 3 is a 6, times x, so that's going to be 6x, and then plus b squared, which is x squared. And I'm going to now distribute the minus sign inside. So I have 2x minus 9, and then minus times a minus is a plus 6x, and a minus times a plus is a minus x squared. Now I can simplify the expressions a little bit further by combining the like terms. So I have negative x squared. I want to put it in the very beginning because this is the highest power. And then 6x and 2x are like terms. Like terms are the ones that have the same variable base and the same exponents but different coefficients. Those terms I will call them like terms. And we can always combine them, plus or minus the coefficient basically. So 6 plus 2 is 8 in this case. So it's going to be 8x and then minus 9. So I hope you got the same answer as mine in this example as well. Alright, so we're making some progress here. So let's move on. The next example I have is to factor special types of expressions. We will look at the expression of the type x squared minus a squared in this slide, and in the next slide we'll look at an expression containing 3 terms. We have a formula here for this types of expression, x squared minus a squared. The formula is going to be x plus a and x minus a. You can verify this formula using the FOIL method. So so maybe this is your little extra homework to verify that x plus a times x minus a equals x squared minus a squared. Let's apply that formula to part A. Here we have to identify which one is the first term and which one is the second term without the square. So without the square, the first term is going to be x, and the second term 16 is the square of 4, so it's going to be x minus 4 and x plus 4 is our answer. Alright, now let's look at part B. In part B, we don't have a square, so it's a little bit tricky. And I'm doing these examples because we're going to use these things in finding limits of functions using algebraic methods. So you'll encounter these things later. So here x minus 2 has no squares on any of these terms, but remember this. Oh, this might look odd to some of you, but x can be written as square root of x and then square, and 2 can be written as square root of 2 and then square. It might be a little bit difficult to grasp this concept at the beginning, but eventually when you see more and more of these examples, you will understand it. So we have here x minus 2, so I'm going to put it in this format x squared minus a squared type, or sometimes they call it a squared minus b squared type, so it doesn't really matter. So we have square root of x squared minus square root of 2 squared, and then it looks like this, the difference of the two squares, so it's going to be square root of x minus square root of 2. Well, you can put the plus first and the minus later if you want to be consistent to this formula here, but it doesn't really matter. So square root of x plus square root of 2 times root x minus root 2, and that's how it goes. Okay, now you can pause this video and work on part C. Alright, so I hope you worked on part C. So let's look at the answer here. We have on the top as x minus 2, and the bottom we have square root of x minus square root of 2. Since I've already worked on x minus 2 as in the previous line here, so I'm going to write this x minus 2 as square root of x plus square root of 2 times square root of x minus square root of 2. And then in the denominator I have square root of x minus square root of 2. I'm not going to further mess up with the square root into further the 4th root and the 8th root. You can keep on going like this in this radical powers, but that's okay. The reason why I'm doing this is because I already know that I am going to have to do something like this in part C, where there is a square root of x. Now as you see, I can cancel these common factors, and this is so useful while you are finding the limit of a function, especially when you have the 0 over 0 forms and then you have trouble using the direct substitution method. So the final answer is going to be square root of x plus square root of 2. Alright, so let me enclose this inside a rectangle. Okay, so we have our last example here, which is part D, and that's going to be x to the 6 minus 16. In this case, we don't have the square, but you know, 6 is an even number, so you can change it into the square of something. So a little bit of trick, which is basically a very standard procedure later on, is this. So we're going to write this as x and then some power and then square minus the 16 is of course 4 squared. We already know that. So if I extract 2 out of 6, then the inside, because when I multiply these two things together I'm gonna have to have a 6, so the inside should be 3. So basically you divide 6 by 2 and then you get a 3. Now you have the exact same situation as before, so it's the difference of 2 squares. So I'm gonna write the first with the plus, so x cubed plus 4, and then the second with a minus, x cubed minus 4. And so of course it doesn't quite look like this one, but you have to know how to manipulate these powers and then apply these formulas. Alright, so let's move on. The next example I have is to cancel the common factor. This should be pretty easy to some of you, but I'm assuming we don't know anything ahead of time. The first example I have is 3x over 4x squared plus 8x. Now this is one of the basic skills that we have to develop in this course before we jump into the calculus part of it. So here you can't cancel the x just like this. You have to have a common factors on the top and the bottom, and then you can cancel the common factors. On the top, there is nothing to factor out because 3 and x are independent factors, or prime factors if you like. In the denominator, you have a common factor. I mean, there is a 4 and 8, so you can factor out 4, and then there is x squared and x, so you can factor out x. So it's going to become 3x on the top, and on the bottom you have 4x as a common factor, and what is left on the first term is x minus the second term has, not minus, it's a plus basically. Second term is going to be 2. And now you can cancel these common factors and write this as 3 over 4 times x plus 2. And this is very useful if during the time of finding the limits, and then also using the quotient rules, and in a lot of other places we need these types of skills when we are in the process of simplifying. Alright, so now pause this video and work on the part B. Okay, so I hope you worked on part B. So let's do this together. Here we have 4h squared minus 5h divided by h. And this type of situation arises while you are finding the derivative or the instantaneous rate of change of a function. So again, you can't simply cancel the h from the top and the bottom without factoring out. So let's factor out the h from the top. So if I factor out the h from the top, of course the numbers have nothing in common, so they will stay back. So 4, and then I took one h's out, so I have one more h left in the first term, minus 5 in the second, and in the denominator I have h. Now I can cancel these common factors from the top and the bottom and write this as 4h minus 5. Let's move on. The next example I have is factoring the polynomials of the form ax squared plus bx plus c, where in this case we're gonna use a equals 1, and b and c are any numbers. They could be positive, negative, anything. We have 3 examples here. I'm gonna work on the first example and then let you work on the second, and then perhaps I'm gonna work on the third. So let's look at the first example. Here we have x squared minus 5x plus 6. So the idea is to look at the factors of the last number. So I'm going to collect the factors in one column, and then I'm going to look at the sum of these factors. Well, I'm doing this first example, am I not? So let's just put a minus sign there instead of the plus sign. Sorry, I copied the wrong example. So x squared minus 5x minus 6. Okay, there we go. So factors, and then in this case, since the last sign is negative, I'm gonna find the difference. So I'm going to make a little table here, and this is going to decide how we're going to factor these things out. So the factors of 6 are, we can always start with the biggest factors. So 6 and 1 are the factors, and the difference of 6 and 1 is 5. And the other factors are 3 and 2, and the difference of 3 and 2 is 1. Always find the difference of the subtract the smaller from the bigger. The sign doesn't really matter at this time. So again, remember, we factored the last number, the coefficient. If there is a variable, you just take the coefficient and write out all the factors, all possible combinations. Here we have only 2 possible combinations. One is 6 and 1, because 6 times 1 is 6. The other is 3 times 2, because 3 times 2 is again 6. You'll have to write the factors only in 2 parts. Sometimes you may have a little more complex or composite number here, for example 24, which may have different factors, but you always have to divide them into 2 parts. and then I'm writing the difference because the last sign is a minus. If the last sign is a plus, which is in the second and third example here, then you'll have to find the sum, as you will see. So based on this result here, I mean this table here, we're gonna have to pick one of the factors whose difference is the middle number, and there is always only one of those factors, factoring groups. So in this case, the first group of factors will give us a 5 after subtracting the factors. So I'm going to choose this 6 and 1. Now if you were familiar with the FOIL method, you can go ahead and write this as x minus 6 and x plus minus 1, or depending on the sign, I mean the plus or minus might be adjusted later. So that is something you probably already familiar with, but my goal here is not to do that method. I'm going to do it in a little bit different method. So I'm gonna have to add a few more terms, and this is gonna be not so interesting for this particular problem, but it can be very useful when you have a coefficient in front of x here. Then this method is really gonna pay you back. So I'm gonna copy the first term as it is, minus, I'm just copying the sign minus, and then I'm gonna break this number 5 into two parts, which is 6 and 1, because 6 minus 1 is 5. So I'm gonna put that breakdown inside this parentheses, 6 minus 1, and then x minus 6. So what I did is I split this 5 into 6 and 1 based on this table here. Now I'm gonna simplify this expression. So I have x squared, and I'm not gonna subtract 6 and 5 because that's going to give me 6 and 1 rather, that's going to give me 5 back. I don't want to do that. I'm just going to distribute the x inside and the minus inside as with one of the examples earlier. So it's going to be 6x, and then minus and minus is a plus, and then x times 1 is x, so plus x and minus 6. Okay, and then I'm going to group this 4 terms into 2 on each group, and then factor out the common factor. So this is going to be in the first group I have x as a common factor, and what I am left with is x minus 6. And in the second I have a plus in front of that group, and then in the second group there is nothing in common. In that case I can always write a 1 as a common factor, because 1 is the factor of every single thing. So if there is just 1 as a common factor, then I have everything left here, so x minus 6. Now sometimes if you have a minus here, then that minus will change the sign inside the parentheses. Now this is a check post or a milestone, if you like, where you can check if your process is going in the right direction or not. In this case, you must have the same factors inside the parentheses, meaning the same expressions inside the parentheses. Now I'm going to do one more factoring. So I have x minus 6 and x minus 6, so I can think of these as a common factor. So I can pull that x minus 6 outside, and then I have x plus 1 left out. So the x is from the first term and the 1 is from the second term. And this is our final answer. Now pause the video and work on part B. Alright, so part B, let's look at the answer. So I have x squared minus 5x plus 6. So nothing is changed except the last sign is changed. So instead of the difference, I'm going to find the sum. So I'm going to have to make this table again. So factors and the sum. So the factors are 6 and 1 and 3 and 2 as before, and the sum of 6 and 1 is 7, and sum of 3 and 2 is 5. So I'm going to choose the second group here and rewrite this same structure. So it's going to be, let me draw the vertical line here. So this is going to be x squared minus 5 is going to be 3 plus 2 instead of 6 minus 1, and then x plus 6. And then I'm going to distribute the x and minus inside, so I have x squared minus 3x, minus and plus is a minus, 2 times x is 2x, plus 6. And then I'm going to group these things into two groups and factor out the common factor. So this is going to be x in the first term, which is going to leave x minus 3, and minus the second group has a factor of 2. So I'm going to put the 2 outside with a minus sign, by the way. So I have x left in the first term, and with the minus being taken out, this plus, whatever sign, sometimes minus, sometimes plus, whatever it is here, that's going to change. So in this case, the plus is going to change into minus. And as I mentioned before, the milestone is right here, where we have the same expression, x minus 3 and x minus 3. So I'm going to pull that x minus 3 outside, and what I'm left with is x minus 2 as the second factor. So this is the answer. Now if you want, you can pause this video and work on the last example. Okay, so the last example we have is x squared minus 8x plus 15. So I am going to use this space down here and write out the factors. And in this case, again, the last number is a plus, so I'm going to find the sum. So the factors of 15, well, there are different factors of 15. One of them is 15 and 1. It's always going to be the number and 1 itself. That's one of the choices all the time. And the other one is 5 and 3. I want to write the larger factor first, and then the smaller factor later. So the sum of 15 and 1 is going to be 16, and the sum of 5 and 3 is going to be 8. So as you see, I'm going to choose the second group of factors. So I have x squared minus 8 now is going to become 5 plus 3, and times x from the right side plus 15. Now I'm going to open this parenthesis by distributing the negative from the left and x from the right. So this is going to be x squared minus 5x, and minus plus is a minus, 3 times x is a 3x plus 15. And now I'm going to group the 4 terms into 2 different groups and factor out the common factors. So the first term has x as a common factor, and what is left is x minus 5 minus the second group has a 3 as a common factor, and then you have x, and the minus will change this plus into minus, and then 5. And as a checkpoint, I have to check if I have the same expressions in both of these expressions, I mean parentheses here, and I do have the same expressions inside these parentheses. So I'm going to pull those out. So x minus 5 as one of the common factors, and the other one is going to be x minus 3. So this is my final answer. Okay, so I hope you learned some factoring. Of course, this is not a detailed lecture on factoring a trinomial like this, but at least you saw 3 different examples, so hopefully you got something out of this. The next set of examples we have here is to find the value of a function. So to find the value of a function, we have to plug the value of the x given to us into the function, and then it's going to be a number or some other expression. So first example we have is f of x equals x squared minus 5x plus 6. This is a 5. Okay, and we're going to find the value of this function at x equals 3. The notation for that is f of 3. That's the value of the function at 3, and that's going to be 3 squared minus 5 times 3 plus 6. So as you see, the x right here is just a placeholder for the value, meaning a number. So x can hold any value as long as that value is in the domain of this function. If you know from college algebra what the domain of a function is. In this case, the domain is every real number, so we're allowed to put any value, but we're already given 3 as the value. Now I replaced x by 3 and then square, in the process of squaring it, minus 5x. So 5 and x are multiplied together, so I can't just write 5 and 3 without any sign in between, because that's going to become a 53. So I have to use this parenthesis to show that they are multiplied together, and then a plus 6. Now I'm going to simplify this a little bit further and write this as one single number. So if I multiply 3 with itself, which is the meaning of the 3 squared, that's going to be a 9 minus 5 times 3 is a 15 plus 6. And if I simplify this further, then 9 plus 6 is 15 minus 15 is a 0. So the answer is 0. Okay, now you can pause this video and work on part B. Alright, so I hope you worked on this part B. So let's look at it together. Here we have f of x equals 3 minus square root of x squared minus 1. And we're finding the value at x equals 2. Now this is a radical function, so you cannot put everything in place of x, because the negative inside the radical is not allowed. That's not a real number, that's a complex number. So we will like to avoid those situations. So let's see if we can do this in our head. So if I plug 2 inside, that's going to be 2 squared, which is a 4, minus 1, which is a 3. So that's a positive number, so we're going to be okay. So let's do f of 2. So that's going to be 3 minus square root of, now in place of x, I'm going to put a 2 there, and then square minus 1. So as you see how I'm using the parentheses while replacing the value of x by the given value, that is always a good practice. So that's going to be equal to 3, and don't think about distributing the minus inside here yet, because the square root is not going to allow you to do that. So we're going to have to simplify this. So the square root here is acting as if a parenthesis is there. So 3 minus square root of, so the 2 squared is a 4 minus 1, and then we have 3 minus square root of 3. So it's not a number that you can simplify any further than this, but if you want to use a calculator, you can punch these numbers into the calculator and get the answer. So let's see if I can pull out my calculator here and show you how to enter these numbers into Alright, so here is my little calculator that is showing up in the screen here. So I'm going to have to enter this number 3 minus square root of 3. So let's turn this on. So this is a TI-84 plus Silver Edition. Any graphing calculator or the scientific calculator should be okay for this type of work, but later we might need a graphing calculator. So in this case I'm going to enter 3 and then a minus. Of course you can't see the keys that are outside the screen, the recorded screen here. Minus, and then the second, and the square root is right here. Oops, that's not correct. So let's get out of here. So 3 minus second times the square root. Okay, I pressed the wrong key, so that's a 3 there, and then enter, and that's gonna give me 1.26749. So I can round it up to 2 decimal places and write this as 1.27. Alright, so let's write the answer as pull the pen. So the answer is going to be 1.27, because as you can see we are rounding it to the 2 decimal places. Now you can round it to any decimal places, but 2 decimal places is what we want to do at this time. Alright, let's look at our next set of examples. We're still working on finding the value of a function, but with more different types of functions. Sometimes finding the value of a function is impossible because the value is not in the domain, or it gives some weird answers. So in the first example I have here, I have f of x equals x squared minus 1 over x cubed. X squared minus 1 over x cubed. So I'm going to find f of 0, and that's going to be 0 squared minus 1 over 0 cubed. So I want to keep my promises that I made earlier to keep all these substituted values inside the parentheses. Alright, so 0 squared is a 0 minus 1 over 0 cubed is 0. But remember, 1 over 0 is not a number, it is undefined. So you have a 0 minus undefined, which is of course undefined. So this is going to be undefined. So it's not a number, it's undefined. We don't know what it is. Okay, now you pause this video and work on part B if you like. Alright, so back here in part B, so we have f of x equals square root of 3 minus x, and we're finding the value of the function at 5. So f of 5 is going to be square root of 3 minus 5, which is going to be the square root of negative 2. And the square root of a negative 2, one of the things you can do is you can check it in your calculator. So let's try that. Square root of negative, so you're going to have to use this little negative down inside the so square root. First of all, let's pull the square root symbol here, and negative 2. There are 2 negatives. I mean, there is a regular plus minus, but there is one negative at the bottom of the calculator. I don't know if I can show you guys this little thing. It doesn't. Okay, right here. So this. Okay, hold on a second. So this one at the very bottom, we have a minus inside the parentheses. That's the one you're gonna use in this case. And then move the cursor outside and then press enter. And see, this is expected. It says error, and then it says no real answers. So that means this is not a real number. This is actually a complex number. So let's do second and mode to quit that error. So the answer is not a real number. So not a real number. So later on we'll have to know how to avoid or when to avoid these types of situations, and what happens when these situations arise. This is one of the cases where we will call them the places or the points of discontinuities of a function. Alright, so let's look at a few more examples of finding the value of a function. So in this case, we have f of x equals x minus 3 over x squared minus 9, and the value is at x equals 2. So f of x, so I'm working on part A. So f of x equals x minus 3 over x squared minus 9, and f of 2 is going to be 2 minus 3 over 2 squared minus 9. So let's simplify this. So it's going to become 2 minus 3, so 2 minus 3 over 4 minus 9, and that's going to be negative 1 over negative 5. So that's going to be 1/5, because the negative and negative cancel. And if you want the decimal answer, it's going to be 0.2. That's your answer. So f of 2 equals 0.2. No problem. We just need to simplify and to calculate these things a little bit. Now pause this video and work on part B. Well, I hope you worked on part B, so let's look at this. So here we have f of x as the same function, so there's no change in the value of the function. I mean the expression, the function expression is the same. So f of x equals x minus 3 over x squared minus 9, and we're finding the value at 3. So f of 3 equals 3 minus 3 over, again, I'm going to put the parentheses around the values first and then simplify that later. So x squared minus 9, which is 3 squared minus 9. And that's going to be 3 minus 3 over 9 minus 9. So if I simplify this, I have 0 on the top divided by 0 on the bottom. And again, this is a situation where we cannot go any further than this. This is another weird situation that we have to avoid. So again, you can try it in your calculator and see how much you get. So let's try dividing 0 by another 0 in your calculator and see what happens. Again, it says divide by 0, error. So the calculator does not know how to answer this. Of course, we made the calculator, I mean our ancestors made the calculator, so they knew it. So here, this type of thing is, of course, there is no answer here. That means we don't have the value, so no value. But we have a special name for this thing, and the name is indeterminate. I-N-D-E-T-E-R-M-I-N-A-T-E. I think that's how it is spelled. So indeterminate form. So of course, this is not something you are expected to know at this time, but you can simply say no values. No value. So, but then the name of this situation or this form is called indeterminate form. So this situation arises while you're finding the limit of a fraction, and then you have to factor out the common factor and then do the direct substitution later. So that's why I wanted to bring up this example here. Alright, so one last slide for, well, it could be one more last slide, one more than this. So find the value of the function at a given point. F of x equals 2 minus x, and then we have to find the values at 1, 1 plus h, 1 plus h minus 1 in f of 1, and then the last one is the fraction, and something called this is called the difference quotient. Okay, so let's look at these values very quickly. So the first one is f of 1. We have the function 2 minus x, so it's going to be 2 minus of 1, which is going to be 2 minus 1, which is going to be 1. So that's straightforward. Part B is going to be f of 1 plus h, and this is where some work has to be done, and then you can't get a number out of it because we don't know the value of h. H is an unknown. So in this case, we're going to have to replace x by 1 plus h everywhere, because remember, x is just a placeholder. So it's going to be 2 minus 1 plus h. And see how it is when I replace h by, x by 1 plus h. I'm using the parentheses here. It's so important that you use the parentheses every time you replace the x by its value. So now you can simplify this. So it's going to be 2 minus, so you multiply the minus sign inside, and it's going to be 1, and then minus and plus is a minus, and then h, and that's going to be 1 minus h as our answer. So we have 1 here as our answer, we have 1 minus h as our answer. Part C is just a combination of the first two answers, because it's going to be f of 1 plus h minus f of 1, so that's going to be 1 minus h minus 1, because 1 minus h is the value of f of 1 plus h, and 1 is the value of f of 1. So after simplifying, we get this as negative h, because I can cancel the common factors. so it's going to be negative h. The last part, part D, is the quotient of f of 1 plus h minus f of 1 by h, so it's going to be negative h over h, and that's going to be negative 1. And later on when we do the derivatives, really this is just a derivative of this function, so if you apply the power rule, it's going to be 2 minus, 2 is going to be 0, and negative x is going to be negative 1. Also, you can find the instantaneous rate of change later on using this method of finding the difference quotient and applying the limit. So this is so important that you understand these things from the very beginning. Now we're going to look at one more type of function and see how we can apply the same idea as before. So in this case we have 2 minus x squared. So in the previous case we just had a linear function, but this one is not a linear, it's a quadratic, so it requires a little bit of work. The first part is straightforward, so it's going to be f of 1 is going to be 2 minus, let's erase this thing. I accidentally put a parenthesis here. So 2 minus, and then I have 1 to replace x, and then a square. So that's going to be 2 minus 1, which is going to be 1. The second part, b, is f of 1 plus h. That's going to be 2 minus 1 plus h squared. Now this is where we have to do a little bit of work. So 1 plus h quantity squared, you have to expand it using one of the techniques we had in the previous examples here. So I'm going to take it all the way up here. So this is going to look like 2 minus, and I'm going to work inside the parentheses first. So this is going to be 1 plus 2h plus h squared. If you don't remember the formula, go back and then view that part of this video, and you will understand how I came up with this idea. A plus b squared equals a squared plus 2ab plus b squared, and that's going to be 2 minus 1 minus plus is a minus 2h minus, because the minus and the plus is a minus, and then h squared. And you can simplify this, so negative h squared, I want to put it at the very beginning, and then minus 2h, and then 2 minus 1 is plus 1. So I got that for f of 1 plus h minus f of 1. Now I want to divide this quantity by h in part D. So part D, just after doing all of this, part D is basically the combination of all of these things with one more step. So it's going to be negative h squared minus 2h plus 1 divided by h. And then of course I just divided f of 1 plus h by h, but I have to do the minus f of 1 also, so there's a minus 1 here. Again, remember, this much is f of 1 plus h, and this is f of 1. So I'm doing f of 1 plus h minus f of 1, and then divide that by h. Now simplifying this, let me just clear these things from here so we're not distracted by this extra stuffs. So I have this, and I'm going to simplify this. So this is going to be, so we can cancel the 1 and negative 1, so we have a negative h squared minus 2h over h. And we can factor out the common factor. This is similar to one of the examples we did earlier. So we got to factor out the common factor of h, and then I have a negative h minus 2 divided by h, and I can cancel those two h's, and then I have finally this is equal to negative h minus 2, negative h minus 2. So and then the story goes a little bit further than that when we are doing the derivative using the definition. So at that time we'll have to apply the limit of h. So when we apply the limit, h goes to 0, then this part goes to 0, and all you have is a -2, which is the derivative of this function right here. So that's another story, the derivative at 1. So that's a different, that's something we will be looking at later. Okay, now as our last example, I have a piecewise, actually a couple of piecewise defined function, and I'm gonna have to find the value of this function, first and second functions at different places. This is so crucial to know how to find the value of a piecewise defined function. When we are doing the discontinuities of a function, we'll have to do these types of things. So it's so important. Alright, so let's look at part A, and I'll let you do the part B and then come back and see the answer. So in part A, I'm gonna have to find the value at -3, 0, and 5. Now here, if you look at the structure of this function, this has got two different branches, or two different pieces. That's why it's called a piecewise defined function. So in the first piece or first branch, we have the value or the formula equals to x minus 1. So this branch is for all the values of x that are less than 0. The 0 is not included in this branch. In the second branch, we have 3x minus 1, and that branch is applied to all those values of x which are greater or equals to 0. So the value of x equals 0 falls in the second branch. So let's move this away from there. Okay, so in part A, there are three values we gotta find. The first one is gonna be f at -3, or f of -3. And so we're gonna have to replace x by -3 in one of the branches. We have to choose which branch the x equals 3 belongs to. And x equals, -3 rather. So -3 is less than 0. That's why it belongs to the first branch. So we're gonna pick the first branch and replace x by -3. Again, remember my parentheses rules. So -3 minus 1. So I did not choose the second branch because -3 is in the first part, where the restriction is x is less than 0, and -3 is of course less than 0. So that's why we're using that. And -3 minus 1 is a -3 minus 1, which is going to be -4. So that's the first part of part A. And then the second part of part A is f of 0. So the value of the function at 0. So which branch are we choosing at this time? Well, the first branch has all the values of x less than 0. So 0 is not included in the first branch, but 0 is included in the second branch. That's why I'm going to replace x by 0 in the second branch. So that's going to be 3 times 0 minus 1, and that's going to be 3 times 0 is 0 minus 1, which is going to be a -1. So this way we found the values of the function at two different places. Now let's look at the last part of part A, which is f of 5. Now 5 is greater than 0, so it's going to be in the second branch. So it's going to be 3 times 5 minus 1, which is going to be 15 minus 1, which is going to be 14 is our answer. Alright, so we have -4, -1, and 14 as our answers. Now pause this video for the last time and then work on the part B. Okay, back here, part B. This time we have 3 pieces instead of 2 pieces in the first example. So we have to be more mindful of these values while we are selecting the right branch. So we have 1, 2, 3, 4, 5 different values to find. So let's find f of negative 3. Well, f of negative 3, so we're going to look at negative 3 here. Negative 3 is less than 0. So there are 3 branches here. The first branch is for those values of x which are less than 0. The second branch is a small portion of the real line where the values of x are between 0 and 2, including the end point, and the last one is to the right side of 2. So we're using the first branch because negative 3 is less than 0. So it's going to be negative 3 minus 4. And that's going to be negative 3 minus 4, which is going to be negative 7 as our first answer. Then we're going to look at the value of this function at 0. For 0, we're going to have to go to the second branch because 0 is included here because of the equality sign right there. So we're going to replace x by 0 in the second branch. Now, the second branch does not have any x. It's a constant. So regardless of the value of x, this branch remains constant throughout 0 and 2, throughout this interval from 0 to 2. So whether you put x equals 0 or 0.5 or 1 or 1.5 or 1.7, there are infinitely many values between 0 and 2, and for all of these values, the values of x, the value of the function is always going to be negative 4. Next is f of 1. 1 again falls into the second branch because 1 is less than 2 and greater than 0. So again the function is constant, negative 4. No place to replace for x. Then the second last is going to be f of 2. 2 again is in the second branch because of the equality sign. So we're going to still write negative 4 for this part because starting from 0 up to 2, all of these values are the same because the function is constant. And the last value I have is f of 3, and that's going to be in this last branch because 3 is greater than 2, so it's going to be the last branch. So it's going to be 7 times 3, and that's going to be 21. Okay, that is all I have for this video. I hope you enjoyed watching this video, and I hope to be back in other videos later.